There is a spacecraft orbiting Venus right now that nobody talks about. It found something in the clouds that should not exist, something that violates everything we thought we knew about that planet. And when the results came back, NASA did not celebrate. They went quiet. By the end of this video, you will understand exactly why that silence was more disturbing than any announcement they could have made. Before we get into it, quick question. Where in the world are you watching this right now? Drop it in the comments. I genuinely want to know. Now, let's go back to the beginning. Most people think of Venus as just another dot in the night sky. Bright, pretty, harmless. The ancient Romans named it after their goddess of beauty, and honestly, from a distance, that tracks. Venus is the brightest object in our sky after the sun and the moon. On a clear night, it can cast a shadow. But get closer and the beauty vanishes instantly. The surface temperature on Venus is 465 degrees Celsius. That is hotter than Mercury, even though Mercury is twice as close to the sun. The atmospheric pressure on the ground is 92 times what you feel standing on Earth right now. If you were somehow teleported to the surface of Venus without a suit, you would not burn, you would not suffocate, you would be crushed and cooked simultaneously in the span of a single second. And yet, Venus is almost exactly the same size as Earth. Same density, same composition, same age. Scientists call it Earth's twin. And for decades, that comparison haunted them. Because if Earth and Venus are twins, how did one of them become paradise and the other become the most hostile place in the solar system? That question drove the first golden age of Venus exploration. Between the 1960s and the early 1990s, both the United States and the Soviet Union sent dozens of spacecraft to Venus. The Soviets were obsessed with it. They built landers specifically designed to survive the surface. Most of them died within minutes. The longest any lander ever survived on Venus was just over 2 hours before the heat and pressure killed every instrument on board. But they kept going back. In 1990, NASA sent a spacecraft called Magellan to Venus. It spent 4 years in orbit, using radar to pierce through the planet's permanent cloud cover and map the surface below. What it found was extraordinary. Thousands of volcanoes, lava plains stretching for thousands of miles, mountain ranges, ancient highland regions unlike anything else in the solar system. A surface that looked shockingly young, as if the planet had been completely repaved within the last few 100 million years. Nobody expected that. Venus was supposed to be geologically dead. Magellan operated until 1994. At the end of its mission, NASA directed the spacecraft to spiral down into the atmosphere, where it burned up and disappeared into the clouds forever. And then, nothing. For 30 years, the United States sent 0 dedicated missions to Venus. 0. While Mars received rover after rover, orbiter after orbiter, lander after lander, Venus just sat there, close enough to see with the naked eye, and completely ignored. Why? The easy answer is Mars. In 1996, a team of NASA scientists announced they had found what looked like fossilized bacteria inside a Martian meteorite. The claim exploded across global headlines. Congress noticed. Funding shifted. Mars became the priority almost overnight. And even after that claim fell apart under further analysis, the momentum never stopped. Mars was accessible. Mars was relatable. Mars had seasons, dust storms, sunsets that looked almost familiar. Venus was alien, hostile, expensive to reach, and nearly impossible to explore. But here is the thing that most people miss. The scientific case for Venus was always stronger. Mars is fascinating, but Venus is urgent. Because Venus did not start out the way it looks today. The evidence is locked inside the atmosphere itself. Scientists measured the ratio of heavy water to regular water in the Venusian atmosphere and found something remarkable. That ratio is 150 times higher on Venus than on Earth, which means Venus once had vastly more water than it does now. The light hydrogen escaped to space over billions of years, leaving the heavier version behind like a chemical fingerprint of a lost ocean. Venus may have had liquid water on its surface for billions of years. It may have been habitable, a second Earth right next door. And then something tipped. As the sun gradually brightened over billions of years, Venus began to warm. Water vapor evaporated into the atmosphere. Water vapor is a greenhouse gas. It trapped more heat, which evaporated more water, which trapped more heat. A feedback loop with no exit. Scientists call it the runaway greenhouse effect. Every ocean on the planet boiled into the sky. Ultraviolet light split those water molecules apart. The hydrogen drifted off into space, the oxygen reacted with surface rocks, and the carbon dioxide that had been locked in those rocks had nowhere left to go. It built up in the atmosphere until the planet was wrapped in a blanket so thick and so hot that the surface glows in the dark. That is what happened to Venus. And here is why that should terrify you. Earth is on the same path. Not today, not in 1,000 years, not in 1,000,000 years, but in roughly 1 billion years, the sun will be bright enough to do to Earth exactly what it did to Venus. Our oceans will boil, our atmosphere will transform, our planet will become unrecognizable. Venus is not just our neighbor. Venus is our future, a preview rendered in acid clouds and molten rock, and we spent 30 years not looking at it. Meanwhile, astronomers have now discovered thousands of exoplanets orbiting distant stars. Many of them are Earth-sized. Many sit in what scientists call the habitable zone, the region where liquid water could theoretically exist on the surface. We look at those worlds and we wonder, are they alive? Are they habitable? Are they like Earth? But we cannot answer that question because we do not fully understand what separates a habitable world from a dead one. We do not know where the line is. We do not know what warning signs to look for. Venus is that line. Venus shows us exactly what a planet looks like after it crosses the point of no return. If we understood Venus completely, we could look at a distant exoplanet and say, that world is safe, or that world is gone. We could narrow the search for life in the universe dramatically, and we have been ignoring it.
Now remember the beginning of this video. The thing that should not exist, the thing that made NASA go quiet. In September 2020, scientists using two of the most powerful radio telescopes on Earth announced that they had detected phosphine in the clouds of Venus. Phosphine, a molecule made of one phosphorus atom and 3 hydrogen atoms. Simple enough on paper, but deeply strange in context. On Earth, phosphine has essentially one source: life. Specifically anaerobic bacteria, microbes that live in oxygen-depleted environments like swamps, animal intestines, and ocean sediments. They produce phosphine as a metabolic byproduct. No known geological process, no volcanic eruption, no lightning strike, no atmospheric chemistry produces phosphine in meaningful quantities on Earth. If you find phosphine somewhere on Earth, you are almost certainly near something alive. And they found it on Venus. Not on the surface, where nothing could survive, but 50 kilometers above the surface, in the cloud layer, where temperatures hover around 25 degrees Celsius and atmospheric pressure matches Earth's at sea level. A zone where, in theory, microbial life drifting in acid droplets could survive indefinitely, carried around a planet by winds moving at over 350 kilometers per hour. The announcement shook the scientific community. Then the backlash came. Other researchers reanalyzed the data. They found processing errors, potential contamination from sulfur dioxide, which has a similar spectral signature. Some concluded there was no phosphine at all. The original team stood by their findings. Nobody could agree. And then, in 2024, new observations confirmed phosphine again. Better data, better signal, and this time, something else alongside it. Ammonia. Another molecule that has no business being in the atmosphere of Venus. Another molecule that, on Earth, is closely associated with biological activity. Another molecule that no existing atmospheric model can explain. NASA did not hold a press conference. They did not announce a discovery. They funded more analysis. They asked for more data. They went quiet in the way that institutions go quiet when they are not sure what they are looking at and they do not want to be wrong. And here's where we stand today. 3 missions are now in development. NASA's Da Vinci probe will descend through the Venusian atmosphere in the 2030s, measuring its chemistry in real time, photographing the surface, searching for answers about when and how Venus lost its water. NASA's Veritas orbiter will map the surface at a resolution 10 times sharper than Magellan, hunting for active volcanoes and geological secrets. The European Space Agency's Envision will study specific targets in fine detail, filling gaps that the other 2 missions cannot reach. For the first time in 30 years, we are going back. Not because it became easy. Venus is still the most hostile environment humans have ever tried to explore. Surface electronics melt within minutes. Conventional spacecraft components fail before they even reach the ground. Every mission to Venus requires engineering solutions that do not exist anywhere else. We are going back because we finally admitted what we should have understood decades ago. We cannot understand Earth without understanding Venus. We cannot search for life in the universe without knowing what a dead planet looks like from the outside. We cannot predict the future of our own world without studying the world that shows us where that future leads. And we cannot explain what is producing phosphine and ammonia in those clouds without going there. Maybe it is geology. Maybe it is exotic chemistry we've never encountered. Maybe it's something stranger than either of those things. Or maybe, just maybe, it's something alive, floating in the acid clouds of the planet we abandoned, waiting to be found. Patient in the way that life tends to be patient, surviving against all odds in the one environment in the solar system we decided was not worth visiting. We do not know yet, but we are about to find out. Venus has been hanging in our sky this entire time, close enough to see without a telescope, full of questions we chose not to ask. The planet that became hell is finally getting the attention it always deserved. And whatever it tells us when we arrive, it will change everything.